Good morning, team.
Good morning, sir.
In this video, we are going to discuss about a case study on encoders, decoders, parity circuits in industrial applications. Digital systems are the heart of the industrial applications, telecommunications, and consumer electronics. The thing like encoder, decoder, and parity circuits has been used for the digital systems widely in a lot of applications. The encoders and decoders will be playing a vital role in digital communication also. Most probably it has been used for data communication, data processing, and error identification. So for this purpose we are using those systems for making them a number of bit generation. So let me see how these binary addition of encoder, decoder, and parity circuits has been used for the industrial applications.
First we are going to see about the encoder. Actually the encoder plays a major role in all the digital and electronic digital system circuits design also, where it is used to monitor and error correction for the digital systems. So
as encoder we are going to give 2 power n input signals and n output signals, so that we are using multiple number of system.
Yes, sir. So that in most of the cases we use for robotics, CNC machines, microprocessors, and also in computing services. For example, in robotics, which mainly plays with the help of microprocessor and also ADC chips. Based on the work functions that has been assigned to it, it calculates the electronic signals into a binary.
So one of the serial transmissions is used to communicate the system effectively.
Yes. And next is CNC machines, where it was mechanical machines but operated with the help of electronic circuits. And other things are computational devices like computers, microphones, and laptops, mobile also, which also works on the encoder decoder. For best example that we use is WhatsApp's encryption and decryption. That is a simple example for encoder decoder. And another thing is microprocessor. The data that has been given to it based on the serial number it differs. So it gives the odd number.
So it just assume their memory allocation. Based on the allocation, we need to communicate the devices.
Yes, sir. And certain things we can also alter it by decoding it also, decoding the encoder.
So decoder finds the importance in data visualization and memory allocation and addressing also. In digital displays, in digital displays of the industrial dashboards, the
conversions of the
decoder converts the binary sensors into human readable numerical values. So in 7 sectors like temperature reading in chemical plants, and also it finds the pressure in the pipelines. So furthermore, to ensure the furthermore in programmable logic
most probably it will be used for revoke the signal systems.
Yes.
Right? Suppose if you want to use the system again, then we are using decoder for getting the information.
So furthermore, programmable logic circuits, it must be following the information, and also it should be ensured that only the intended values must be curated and essential for the decoders.
Okay, now I'm going to explain about the parity generators in industry. Actually, the parity generators play a vital role in ensuring error detection in communication. The parity generators, in IoT networks, the parity generators are actually the visions and the sensors that can detect the vision and sensors.
So the parity generators normally generated based on the odd and even numbers. So if you are having any problems with that, we are using parity checkers for avoiding the errors.
Actually, the parity generators append an extra bit to the transmitted information to detect the single bit errors. For example, in an oil refinery, multiple pressure and temperature sensors transfer the data to the central monitoring system. The parity generators actually acts the odd and even bit parity before sending the signal to the serial communication system. So actually, even if the noise or interface affect the transmission, it can detect it and it can request for the retransmission. These parity generators actually prevent the faulty readings and can lead to the hazardous condition.
So it may give some authentication to the users, so that they may get the awareness about the information.
So next we come to about parity checkers. From that we are having encoders and decoders. why we need actually the parity circuits. Actually, when we in one of the transmission of the data from encoders, it is encoded to zeros and ones, that is like to binary numbers. And after that, in the process of the decoder, it is actually decoded to the written actual value that binaries to actual data we need, the user need. So what happens if the transmitted data from binary to the actual data, that transmission processor varies, and anything that errors in the, all in it is in the form of binaries, zeros and ones. So what happens if any error arises? So we need to find that error, what it arises. So we are using the parity.
Based on the users, we are using the 3-bit or 4-bit for making the corrections.
Yes, sir. In 2-bit and 3-bit operators, the inputs and outputs vary.
Suppose if the user want to single-bit transmission means we need to check the parity whether it is an odd or even. So if it is odd, then the number of turns will be in odd numbers.
Yes, sir.
So we need to check those conditions while transmitting.
Yes, sir. Same like in even function, sir. Whether even the zeros and ones are to check in a parity. Apart from the theory learning, in industry applications, some of the industries such as aerospace systems and biomedical and in agriculture fields, where they are using the wireless sensor networking. So the transmission of the data is from the binary, that is from encoder to binary, and decoder to the actual value. So
they are formed as a cluster. Based on the cluster, we will get the information through the nodes.
Yes, sir. So all are happening in nowadays in 5G technologies. We are only using through wireless.
So recently they are using for reflection intelligence surface for antenna to receive the information.
Yes, sir. They are all are based on wireless networks, sir. So also in nowadays automatic driving cars such as Tesla's automatic driving cars, that has encoder and decoder using nearly to 1 gigabyte for actually the so the nearer the error transmission data. So they are using what happens if they are transmitting data in a large amount of period. So they need some of errors rectifications. So we are using this parity circuits. Also in the biomedical applications such as now doctors to find the heart rate of the patients, whether they really monitoring the real-time data using.
So through the remote trace, we will get these
information. So it is very critical for the biological applications.
So this will be useful for ICU patients.
Yes, ICU patients, and it is mainly implemented in biomedical
So before we conclude this case study, once we recall the topics we have discussed in the case study, so we discussed about 3 topics: encoder, decoder, and parity circuits. So encoder basically simplifies the input control and also precision time. Decoder facilitates visualization and also memory operations. And finally, parity circuits safeguard the transmission errors. So together these digital circuits ensure the reliability and efficiency.
And accuracy also we will perform. So from this we have concluded that so even though these are some small circuits, but their application in industry perform a lot of applications in future. Thank you.
Thank you, sir.